Hello everyone, welcome to the first AMC 10-12 class. Today we're going to be talking about polynomials. Let's start off with the quadratic formula states that ax squared plus bx plus c equal to 0, then x will be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, the discriminant of a quadratic. So if b squared minus 4ac is 0, so b squared minus 4ac is this part over here. So this part, b squared minus 4ac in the quadratic formula, if that's equal to 0, then the quadratic has a repeated double root. If it's negative, then the quadratic has no real roots. Basically, the reason this is true is if you plug into the quadratic formula, if it's 0, you'll have two roots like 3 and 3, for example. It's a repeated double root. So if b squared minus 4ac is positive, then this quadratic has two real roots. In a given quadratic, ax squared plus bx plus c is 0. There's also Vieta's formula, which tells us the sum of the roots is going to be negative b over a, so negative of this coefficient divided by this coefficient. And the product of the roots will be equal to c over a. So basically, we take the constant coefficient divided by the x squared coefficient. So now let's take a look at the background. Let's take a look at some other problem that uses this technique. Here, let's take a look at a problem that's a basic application of Vieta's, just to give you an idea for how Vieta's works. Basically, in this equation here, this quadratic, we want to find the sum and product of the roots. And we can do that with Vieta's formula. So what we do is we do negative of this coefficient divided by this coefficient. So the sum of the roots is going to be equal to negative of negative 24 divided by 2. So a way that, remember, if you're having trouble remembering it, the sum of the roots is a negative of the x coefficient divided by the coefficient of x squared, and the product of the roots is a positive of the constant coefficient divided by the coefficient of x squared. So the sum of the roots is going to be 12. And the product of the roots will just be equal to 17 over 2, or 8.5. Because the product is going to be the constant coefficient divided by the x squared coefficient. So basically, just to summarize, and whenever we have any quadratic, the sum of the roots is the coefficient of the x term, the negative of the coefficient of the x term, divided by the coefficient of the x squared term, and the product is the coefficient of the constant term divided by the coefficient of the x squared term. Okay. Okay, so now let's take a look at the next problem. Okay, so in this equation here, there are two values for a such that the equation has only one solution for x. What is the sum for these values of a? So what we want to do here is we have this equation here, and we have two x terms, ax and 8x. So we want to combine those terms. So we do 4x squared plus a plus 8 times x plus 9 equal to 0. So now you combine these x terms so that it does work. Okay, so we combine these x terms to get this quadratic here. And now what do? Well, what we do is we look at the discriminant, right? Because we want to have only one solution for x. And if you remember on the previous page, it will have a double repeated root or only one solution if b squared minus 4ac is 0. So we want to have b squared minus 4ac to be 0 in order for there to be one root. So then we have a plus 8 squared minus 4 times 4 times 9 has to be equal to 0, right? Because the discriminant is b squared. This is b squared minus 4 times a times c. And if the discriminant is 0, then it's going to have 2 repeated roots. If the discriminant is 0, then it's going to have the same root. So it's only going to have one root, one solution. So if it's only going to have one solution, that's what's going to happen when the discriminant is 0. Okay, so now what we can do here is we have a plus 8 squared will be equal to 4 times 4 times 9 equal to 144. So then what we can do is we can take the square root of both sides to get that. A plus 8 will be 12, or remember, it can be 12 or negative 12. So a plus 8 can be 12, or a plus 8 can be negative 12. Right? Because when we square both of these expressions, if we square a plus 8 to get a squared, we can square 12 to get 144. We can also square negative 12 to get 144. So these are two possibilities. Because if we square both sides of the equations in both of these equations, we get that a plus 8 squared is equal to 144. So from here, what we can do is we can solve for the value of a. We can see that a is going to be equal to 12 minus 8, or 4. We can also see here that in this case, we have a equal to negative 12 minus 8, or negative 20. So overall, the sum of the roots is just 4 plus negative 20, which is negative 16. The answer. Okay, so if you have any questions, you can put it in the chat. Okay, so now let's continue. So in this problem, we have another equation here. We have a and b be the roots of the equation x squared minus mx plus 2 equals 0. Now we're saying, suppose that a plus 1 over b and b plus 1 over a are the roots of the equation x squared minus px plus q equals 0. What is q? And yes, the video will be recorded afterwards, so you can always watch it later. So what do we do here? So our first thing is just use Vieta's formula, right? So what does Vieta's formula tell us? So in this, let's look at the first quadratic. X squared minus mx plus 2 equals 0. So in this first quadratic, we know that the sum of the roots, so a plus b, will be equal to negative of negative m over 1. Right? Negative of negative m over the coefficient of x squared, which is just 1. So basically you have a quadratic. You take the coefficient, the negative of the coefficient of the x term, divided by the coefficient of the x squared term. And for the product, a times b, we do the coefficient of the constant term divided by the coefficient of the x squared term. So no negatives. So it's just going to be 2 over 1 equal to 2. So hopefully Vieta's is a little bit more clear now, which is going to be equal to m. So a plus b is m, ab is equal to 2. But now we have this other quadratic here, x squared minus px plus q equal to 0. So if a plus 1 over b and b plus 1 over a are the roots of this quadratic, what can we do? Well, what do we know really? We want to find q. We really want to find q. So p does not really tell us anything. We really just want q. So what is q? Q, so we know that the product of the roots, so a plus 1 over b times b plus 1 over a, will be equal to, remember, the constant term divided by the x squared term, so q over 1, which is equal to q. So we want to find this value. We want to find q. So we really just want to find the product of these two expressions. So what can we do? Well, we can expand this whole thing out. So you can do a times b, which is ab, plus a times 1 over a times 1 over a, which is 1. A times 1 over a is 1 because the a's cancel. Plus b times 1 over b, we just do b times 1 over b to get another 1. Plus 1 over b times 1 over a, which is 1 over ab. This is equal to q. So how can we find q? Does this seem familiar? This ab term here. It seems familiar, right? We know the value of ab is 2 from our first quadratic. So if you know the value of ab is 2 from our first quadratic, we can substitute it back in to get that 2 plus 1 plus 1 plus 1/2 equal to q. And this is just going to be equal to 9/2. 9/2 is equal to this. So q will be equal to 9/2, and that's the answer. And if you're having trouble memorizing Vietas, here's a way that you can try remembering it. The product is going to be equal to the positive of the constant divided by the x squared term, and the sum is the negative of the x term divided by x squared term. And then what you can remember is that positive is product, and they both start with p. So positive is product, and the other one, sum, is negative. And in general, you want to apply Vietas whenever you have a quadratic, you have roots, and you really just want to find some expression in terms of those roots or something to do with those roots. So typically, you want to use Vietas when you have to find something in terms of the roots, but you don't want to find the roots themselves. So those give you equations that you can manipulate and work around to get whatever expression you want to find. But if you want to find the individual roots, then Vietas is not going to help you much. Now let's take a look at our next problem here. What is the sum of the reciprocals of the roots of the equation here? You might be wondering, why is this in the quadratic section? This isn't a quadratic, right? This has a 1 over x term, right? It has a 1 over x term. So why is it in the quadratic section? This doesn't really seem like a quadratic, right? What we can do is we can multiply a whole equation by x. So if we multiply the whole equation by x, we get 2003 over 2004 x squared plus 1 times x is x plus 1 over x times x is just 1 plus 1 is 0. So now what can we do? I'll give you a minute to try it from here, about 1 minute to try it from here. And we want to find the value of the sum of the reciprocals. So we want to find 1 over, let's say, r plus 1 over s, where r and s are our roots. So try to see how you can figure out 1 over r plus 1 over s. Okay, so now let's continue. So what we can do is we can say that 1 over r is s over rs, and 1 over s is r over rs. So when you combine them together, we get that this is going to be equal to r plus s divided by r plus s. Does it seem familiar? Yes, it does. R plus s, rs. We can just find them using Vietas. So we can find them using Vietas in our quadratic here. And oh, I should have mentioned that something you should remember here is that multiplying by x won't always work. Remember that x cannot be equal to 0. This is like something that you should always remember, that x cannot be equal to 0. Because if x is equal to 0, then this becomes 1 over 0, which is undefined, which won't work. So remember, whenever you're multiplying by some terms necessarily, you sometimes get extraneous roots. So in this case here, we cannot have x equal to 0. So make sure to remember that x cannot be 0 in this case. So we'll just put that to the side. But as you can see here, x equals 0 is not a root of our quadratic, so we're good. So we're allowed to multiply by x because x equals 0 is not a root. So make sure to remember that because it won't always be that case though. Okay, so now we can continue on. So we want to find r plus s and rs. we can use Vieta's formula. So we can see that r plus s will be equal to negative of the x coefficient, so 1, divided by the coefficient of x squared, which is 2003 or 2004. 2003 over 2004, which is going to be negative of 2004 divided by 2003, right? Next, we have rs is going to be equal to 1 over 2003 over 2004, equal to 2004 over 2003. Right? Remember, we're just doing some manipulation here. So we found the value of r plus s. We found the value of rs. So now we want to find the value of r plus s over rs, which is just going to be equal to r plus s is negative 2004 divided by 2003. Rs is 2004 divided by 2003. This will be equal to negative 1, the answer for this problem. This is not the answer, so I should just unbox that. So that's the main idea in this problem, is seeing that the sum of the reciprocals is quite complicated. So rather than finding the actual roots, we can make it into an expression we know how to deal with. So we converted this into expression r plus s over rs, which you can very easily find. And somebody who asked earlier, how do you know when to apply Vietas? This would be one of those problems where you want to apply Vietas, because this is like a complicated expression if you're just to find r-ness individually. But when you combine it together to get this expression, nice and solid expression that's easy to find, you know that, oh, if you're not finding the individual roots, maybe Vietas can help. Okay, so now let's take a look at the next problem. The quadratic equation x squared plus mx plus n has roots twice those of x squared plus px plus n. So basically, all the roots of x squared plus mx plus n are twice those roots of x squared plus px plus n. And we have that none of these are 0, so we don't have to worry about that stuff. We want to find n over p. Okay, so the roots are twice. So let's say the roots of x squared plus px plus m. Let's say the roots of these are r comma s. Let's just say. Let's say the roots of x squared plus mx plus n have roots of 2r into s, because we're given that the roots are twice those of x squared plus px plus n. So now, again, we can use Vietas because we see these terms here. We want to relate r and s to the quadratic. So we have that r plus s equal to negative of p divided by 1. So negative p divided by the coefficient of x squared, or 1, which is negative p. And we have rs equal to m divided by 1, which is just going to be m by 1, or m. So now we can look at the second equation now, right? Let's look at the second equation. Okay, so the second equation, we know that 2r plus 2s equal to negative of m divided by 1. Let me just move that a little bit lower, because I don't want to. Let's move it here. So let me just separate these two out. So we have that 2r plus 2s is negative m over 1, or negative m. And 2r times 2s is going to be n over 1, or just n. So now what do we notice here? What do we really notice? We want to solve these kind of equations. So we have 2r plus 2s. We have r plus s. We know that 2r plus 2s is going to be equal to 2 times r plus s. And what is 2 times r plus s? Well, we know r plus s is negative p, so this is going to be equal to negative 2p. So now we know that negative m is negative 2p, or this means that, so we know that negative m is negative 2p, and that means that m is equal to 2p. So hopefully that's clear, because we just take negative of both of these expressions. Because we know that these two are equal, and we can find Vietas. We also know that 2r plus s is negative 2p, so we know m is 2p. Okay, now we know n. 2r times 2s is n, but 2r times 2s is also 4 times r times s. 2 times 2 is 4, r times s is rs. We combine them together, 4rs equals to n. And 4rs, again, we know that it's going to be 4 times R. Let me just make it a little bit more clear. Let's say that 4 times RS. And 4 times RS, well, RS is M, so it's going to be 4M. So we have this one equation here. And you have another equation, which means that N equal to 4M. I'm going to circle these both, because we're going to use them now. Okay, so now what? We know that N is 4M, M is 2P. We want to find N over P. Well, if N is 4M and M is 2P, then 4M will be 8P. Or 4 times 2P. Let's just say that 4M is going to be 4 times 2P, which is 8P. So N will be 8P. So if N is 8P, then we have N over P equal to 8. And that's our answer. So hopefully that was clear. So that, just to summarize the main things, so we let the roots be RS to S. We knew that R plus S is equal to negative P, and RS is equal to M. And then we did the same thing for 2R plus 2S, and 2R times 2S. And then we made some substitutions here to find that N is equal to 8P. N is equal to 8P, right? N is equal to 8P. And then we found N over P to be 8. Okay, so now let's take a look at our next problem. This we're using a little bit of a function here. Okay, so let f be a function for which f of x over 3 So f of x over 3 is equal to x squared plus x plus 1. We want to find the sum of all values such that f of 3z is 7. Okay, so how can we approach this? Well, we immediately see that f of x over 3 is x squared plus x plus 1. So what we really want to somehow plug in f of 3z into our function here. Because we know the value of f of 3z. We know the value of f of 3z to be 7. So we somehow want to get 3z to be the input of our function. So we want to input 3z. So let's just say that x over 3 equal to 3z, or x equal to 9z. We multiply by 3 to both sides. Okay, so if we plug in x equals 9z into our equation here, we get that f of 9z divided by 3 is equal to f of 3z, right? Is equal to 9. Again, we have x is 9z. I should just box this or make it clear that's there. This will be equal to, since we know x is 9z, it's going to be 9z squared plus 9z plus 1. Okay, so now we know that, now we have our expression for f of 3z. We know this is equal to 7, right? Because f of 3z is 7. So now we know f of 3z, or this quadratic, is 7. We can now solve this quadratic. We can solve the quadratic, so we can expand. What is 9z squared? That's just going to be 81z squared. Plus 9z plus 1 equal to 7. We can subtract 7 from both sides to get 81z squared plus 9z minus 6 equals 0. So now what? Well, now what we can do is we can just use Vietas again, right? We want to find the sum of all values of z such that this is true. So use Vieta's formula. The sum of all values such that it's true is negative of 9 divided by 81. So it's going to be negative of 9 divided by 81, which is negative 1/9. Okay, so the sum is going to be negative 1/9. That's good. That's the answer, actually. And just to summarize the key steps that we did, is that we know that we know that f of 3z is 7. So of course, we want to use this fact somehow. We want to somehow plug in 3z into our equation here, our equation. So if we let x equal to 9z, then we get f of 3z, or f of 9z over 3, is going to be this expression, which is 7. And then we can just do basic Vieta stuff like we always do and get our answer. And this also illustrates another key idea that will come up again and again, even as you go into harder problems, is that whenever you're stuck, look at information you have not used yet. Because most of the time, not all the time, but most of the time, the problem involves you to use all the information. So let's say you've used one fact that the problem gave you, but you haven't used the other fact or two. And then you can think that how can you use those facts to help you get your answer? So that's a general very good strategy to always use. They'll help you move forward through the problem when you're stuck. And we'll actually see that later in the problem. So let's take a look at our next problems here. So the sum of all real numbers such that we have the absolute value. Oh, now we're having some absolute value stuff here too. Is 2. Okay, so there's two cases here. We either have x squared minus 12x plus 34 is 2. That's one case. The other case is where we have negative of x squared minus 12x plus 34 is 2. These are two cases, so let's draw a line between them just to not get them confused. So these are two cases because, remember, absolute value will make a negative number positive and keep a positive number positive. So now I'm going to give you 2 minutes, 1 or 2 minutes to try this problem for yourself, and let's see where you can go with this. And some people are actually mentioning in the chat, Vietas is a trap. That is correct. That if you use Vietas, you run into the issue with the double root, and I'll actually explain that more later. That is definitely true. If you use Vietas, there's a double root in this quadratic. In this quadratic here, there's a double root. So Vietas will give you a wrong answer. It was in fact a very common wrong answer for that question. So. Okay, now let's get into the solution for this problem. So basically, I'm going to show you the way how to actually solve it first, and then I'll show you the way that's common trap later. So the first thing here is you subtract 2 from both sides to get x squared minus 12x plus 2. Right now I'm doing the correct solution. Plus 32 equal to 0. And then you can factor this, or use the quadratic formula, whatever you want, to get x minus 8 times x minus 4 is 0, meaning that x is 4 or 8. Okay, so that's one case here. Because if x is 4 or 8, then this quantity becomes 2. And the absolute value of 2 is just 2. And then we do the second equation here. What we do is we multiply by -1 to both sides. So if we multiply by -1 to both sides, we get x squared minus 12x plus 34 is -2. Okay, so if it's equal to -2, now we add 2 to both sides to get x squared minus 12x plus 36, which factors as x minus 6 times squared equal to 0, which means x has to be 6. So overall, the sum of roots is 4 and 8 and 6, so we have 18 total. That's the correct answer. Now here's the way that somebody mentioned in the chat, that's actually a trap method, a trap that many people got wrong that year. So the trap is basically, what you do is, let's just move this down. This is the correct, I'm going to move the correct method down a little bit. Move the correct methods down, so let's move that down so I can show you the incorrect method. So 18 is the correct answer, and the common trap is that, okay, it looks like it's, yeah. Okay. We see that the sum of the roots is just going to be 12 over 1, or 12 And the sum of the roots here is going to be 12 over 1, or 12 again. And they say, okay, the total sum is 24. That's wrong. Because we have that, there's a double root. So basically, as you can see here, there's a double root. And as you can see here, as I move that down there, when we factored this expression, we got x minus 6 squared is 0. So the only root is 6. But if you think about when expanding it, it's x minus 6 times x minus 6. So you can think about there's 2 roots of 6, but that's the same thing as just having 1 root. So there really is only 1 root, or a double root, because there's 6 and 6 when we factor it. Because remember, when we expanded x minus 6 times x minus 6. So hopefully that brings up the common error that you don't want to do, of course. And now let's hopefully take a look at the next section. Okay, so higher degree polynomials. Okay, so a polynomial an times x at n plus n minus 1 times x at n minus 1 all the way till a0, 0, 0 with the roots r1 through rn. So this is a general polynomial. So then we have, it can be represented as an times x minus r1, x minus r2, x minus rn all the way to rn. And this is a bit confusing. So basically, if you have any polynomial can be expressed in the form an, the first coefficient here, times x minus each of the roots. That's just a way of expressing polynomials in general. So for example, you can have like a polynomial 3 times x minus 2 times x minus 3 times x minus 4 equals 0. And this will have roots of 2, 3, and 4. Because you can factor it as x minus 2 times x minus 3 times x minus 4. So the 3 roots will be 2, 3, and 4. And this is the constant in the beginning. Okay, so now from Vieta's formula here, we have the following conditions. R1 plus R2 all the way to Rn is equal to negative of, so it's very similar to the quadratic Vienas, except it's slightly more complicated. So we do this term, this coefficient divided by this coefficient, the negative of that, right there. That's going to be the sum of all the roots. And then we do the sum of the pairwise products is going to be a of n minus 2 divided by a of n. Sum of the triple products is going to be, this is error here, Latic error, it should be Rn minus 1 in the subscript. Is going to be negative of an minus 3 over an, and so on, all the way until here. Basically, each time I'm going, and if it's a little bit confusing, don't worry, I'll take an example to hopefully clear things up. So don't worry if you don't get it now, hopefully after taking an example, it'll become a whole lot clearer. So here we have basically the alternate in signs. You start with the sum is negative, pairwise is positive, triples are negative, and so on. And that was probably confusing, but an example should hopefully clear it up. So we have this example here. The polynomial has roots p, q, r, and s. Find the sum, product, and pairwise sums of the roots. So basically, we have that p plus q, the sum, plus r plus s, will be equal to these Vietas. Negative of this term divided by this term. It's very similar to the quadratic case, right? Negative of negative 14 divided by 1, which is 14. And then we also have that PQ plus PR plus PS plus, there's a lot of them, plus QR plus QS plus RS. These are the pairwise. This is my main pairwise sums. You basically take all 4 roots and then take all the pairwise sums. You do P times Q, P times R. So you imagine and if you imagine 4 things, you take the sum of all the pairs of products. So if you take P times Q, P times R, P times S, Q times R, basically all possible pairs of sums. Let me look in the chapter at some questions that people are having. Oh, so somebody that basically Vietas, you always take the first coefficient. So you do this coefficient the negative of this coefficient divided by this coefficient is a sum. And then for the pairwise product, oh, this will be equal, I forgot to mention that. This will be equal to 71 over 1, which is 71. So for the pairwise sums, you do this coefficient over this coefficient. And for the cube, for the 3 triple sums, for the cube sums, we have PQR plus PQS plus PRS plus P plus QRS. This is a pair. These are all triple sums. So you basically take all possible products of 3 numbers. Take all possible products of 3 numbers. That's going to be equal to, again, so a way I like to memorize, not memorize, but like basically how do I actually get these equations? I do, this will be negative, this will be positive, this will be negative, this will be positive. So whenever you're doing the coefficients, the sum of all the 1 products will be, the sum will be this first term divided by this term. The pairwise will be this term divided by this term. The triple products will be this term divided by this term. And the product, all 4 roots, which I have not written, the triple product is going to be negative of negative 54 by 1, which is 154. And then from here, we look at the final one, which is the product of all 4, P times Q times R times S. Is going to be negative, positive, negative, positive. I've already written it there. You alternate signs. And then the product of all 4s is basically, the product of all 4s will be the last coefficient. So positive coefficient divided by 1. So 120 divided by 1 equal to 120. So in general, if you have a polynomial, we look at the sum will be the negative of the coefficient divided by the x to the 4th coefficient. The sum of all the pairwise products will be the 71 term positive of that. So it looks like it's a little bit confused based on the chat. So just take a quick another example just to hopefully get feel. This time it's only going to be cubic. It's not only going to be cubic. So x cubed minus 7x squared plus 6x plus 2 equals 0. So in this cubic here, we have that the sum of the roots is going to be negative, positive, negative. Just you think about it as alternating. You start at negative, positive, and then you keep alternating onwards. So the sum, so let's say that the roots are a, b, and c. Or yeah, let's say the roots are a, b, and c of this new cubic. We have the a plus b plus c. 3 roots will be negative of negative 7 divided by 1, the coefficient of the x cubed term. So you know why I keep dividing by 1? Because I'm dividing by the coefficient of the x cubed term. This will be 7. And some of the pairwise, some of you are getting confused by what pairwise means. Basically means you have 3 roots. You take a times b, a times c, and b times c. So you take ab plus ac plus bc. That's what it means by pairwise sums. Is equal to 6. And then we take the product. So product of all 3. 6 divided by 1. And you know why I keep dividing by 1? Is because I keep dividing by the coefficient of x cubed, right? Which is just 6. And then we have abc, which will be negative. Again, we alternate. So this is a negative term. So that's why we're doing negative of this time. So negative of 2 divided by 1 equal to negative 2. So is this clear to everyone? Yeah, higher roots do come up pretty often. So if it's clear to everyone, please let me know in the chat. Or if you need anything clarification, feel free to put in the chat. Okay, looks like it hopefully makes sense now. So now, if it's still not clear, hopefully a few more examples will clear it up even more. So this is the AMC 10 example from the 2010 AMC 10. So the polynomial has 3 positive integer roots. What is the smallest possible value of a? So let's just write it out. Let's just say our 3 roots are r, s, and t. So you have the r plus s plus t equal to, again, we do negative of the x squared term divided by the x cubed term. So I just like to write it out in the beginning, so hopefully to make it more clear for everyone. So you do negative of negative 1 divided by the x cubed term, which is 1. Then we do the sum of the pairwise ones. So rs plus rt plus st equal to b divided by 1, or b. So b divided by 1, positive b divided by 1, or b. Okay, so basically the pairwise sum is basically just you're taking all the possible products, and that's going to be equal to b. But this is actually not really relevant for the problem. I'm just writing it out for completeness. We also have r times s times t is equal to, this is a negative term, so negative of negative 2010. Negative of negative 2010 divided by the coefficient of x cubed, which is 1, which is 2010 divided by 1, or 2010. So now we have these three equations. Okay. So now what can we do, really? So we want to find the smallest possible value of a. Oh, whoops, I accidentally wrote 1 here. I meant to write negative a over 1. Sorry about that. It's going to be a. So a is the sum of the roots. Yeah, it should have been a. So r plus s plus c is a. I accidentally wrote 1 because I was reading there, but it should be a, b in 2010. So you want to minimize a, the sum of the roots. So if you want to minimize the sum of the roots, what we want to do is we want to make the term the smallest possible. So the only thing we really know is that RST is 2010. So we can factorize, prime factorize 2010, so that it's 2 times 3 times 5 times 67. And we have that RST has to be equal to this. Okay, so RST has to be 2 times 3 times 5 times 67. We want to minimize r plus s plus t. So basically what we do here is we want to do, in order to minimize r plus s plus t, we're going to choose that rs and t will be 5, 6, and 67 in any order. And I'll explain why this will be the minimum in a minute. And yes, it does work for any size polynomial, this Vieta trick. So I'm not going to go, it's 67. So basically I'm not going to go into computation here, too much into computation here. But the idea is you just prime factorize it. I'm not going to go into computation. You can work it out on yourself. But it's just a prime factorization I did. So 5, 6, and 67. That's going to be the minimum value sum. And that's going to cause a sum of 5 plus 6 plus 67, or 78. And you might be asking, why is it the minimum sum? Why is it not something else? The reason is, you always get the minimum sum when we have the numbers that are closest together. So, because the product is 2010, a large number, we want to have the numbers as close to each other as possible. So we want to have less super large numbers, and we don't want to have any super small numbers either. So for example, just to make it clear, let's say we took some other number. Let's say we did 2, 3, and 5 times 67, which is 335. This is where we have 2010. The product of 2, 3, and 335 is 2010. But now we have the larger numbers being very large and the smaller numbers being very small. As opposed to here where all the numbers were not as big or small in the middle. So as you can see here in this case, the sum was going to be ginormous. The sum is going to be 340, which is way, way bigger than 78. Because when the numbers are closer together, then you get the smallest possible sum. When the numbers are farthest apart, then you get a very large sum. Okay, so that was it for this problem. And just to summarize, we use Vietas. We know that this product is 2010. Then we prime factorized it and see that the smallest sum is when the numbers are close to each other as possible. So the numbers will be closest to each other as possible when we have the smaller numbers. The numbers have not be that large or be small. The stream will all be in the middle. Okay, so now we're going to do a short break. So we're going to do raffle prizes here. So there's going to be raffle form, and we will be raffling prizes. Next class, the winners will be announced. For the winners of the raffle prizes, thanks to the sponsors, Daily Challenge with Potion Low, Art of Problem Solving, Wolfram, and Brilliant for sponsoring this. And I highly recommend you check these sites out. They're all really great. And now you can fill out the form. It will be put in the chat. And you should be able to fill it out for a chance to win a raffle prizes next class. And the winners of the raffles will be announced next class, so make sure to join for that. And also, if you're watching the video, and if you're not watching it live, if you're watching the video, the link will be in the description. So basically, the raffle, people who fill out the form this class, or the people who watch the video and fill out the form, will get a chance to enter the raffle, which will be announced next class. Somebody's asking how you got from 2 times 3 times 5 times... Oh, it's not 6 times 7, it's 67. This is 67, not 6 times 7. And then I just say, okay, we can combine 2 times 3 to get 6. So it's 5, 6, and 67. And while you're waiting, we're going to have a short break right now. So while you're waiting, you can either try this problem or you can take a break. We're going to take a break for a few minutes, and then we're going to resume later. There will be 2 winners. The sum of the numbers will be, basically, whenever you taking the product of 3 numbers, the sum will be smallest when you're trying to... We have a fixed... Yeah, just like in chat, you have a fixed product, and you want to minimize the sum, so you have the closest together numbers. Because if you have, for example, 1, 1 in 2010, as opposed to 6, 5, and 67, now you have this ginormous 2010 term that's lingering around, as opposed to the smaller terms. Okay, so now let's begin with this problem. And it might seem a little bit scary at first, but it's actually a really good solution. So you should definitely stay for that. Okay, so the roots are a, b, and c. And the roots of this new cubic is a plus b plus c, and c plus a. We want to find t. Okay, so what we want to do here is we see that a plus b plus c. Again, we have Vieta. So we have this cubic. We can use Vieta. So we have x cubed plus 3x squared plus 4x minus 11 is 0. And we have the 3 roots are a, b, and c. So you have a plus b plus c equal to negative 3 over 1, which is negative 3. And we have ab plus ac plus bc equal to 4 over 1. So again, negative, positive, negative. I just want to write that out. Then it's going to be 4 over 1 equal to 4. Then we have a, b, and c. Product is going to be equal to negative of negative 11 divided by 1 equal to 11. And now we just use Vietas, right? So now that we use Vietas, now we have these 3 equations, right? Because now that we have these 3 equations in terms of a, b, and c, we can find a plus, we really just want to find t. So now we have this new next cubic. We have this new cubic here. I don't want to hide it. X cubed plus rx squared plus sx plus t equals 0. And we have, again, negative, positive, negative. So negative, so we have that the product of the roots, so the product of the roots is going to be a plus b times a plus c times b plus c. The product of the roots will be negative of t over 1. The coefficient of x cubed is 1, which is negative t. Okay, so now we have these three products of negative t. So now what can we do? Well, now what we can do is we can see that if the product is negative t, we can see that the sum of the roots is going to be a plus c will be negative 3, meaning that negative 3 minus c times negative 3 minus b times negative 3 minus a, this product right here will be equal to a plus c. And the reason this is true is because we have that the sum of the roots is going to be negative 3. So a plus c is negative 3, meaning that we can subtract c from both sides to get a plus b is negative 3 minus c. See, I'm using a really clever trick here. So then here what we can see is we can see that, okay, if a plus b is negative 3 minus c, and we similarly have a plus c, we subtract b from both sides, we get equal to negative 3 minus negative b, and we have b plus c is equal to negative 3 minus negative a. And now what we can do is we can just expand this out. So now we know that it's just going to be negative 3 minus c, negative 3 minus b, negative 3 minus a. So now what can we do really? We can actually plug in negative 3 to our polynomial. So just to clarify what that means is that in our polynomial here, we have that x cubed plus 3x squared plus 4x minus 11 is going to be equal to x minus a times x minus b times x minus c. Okay, so if we have this cubic is equal to x minus a times x minus b times x minus c, this cubic is equal to x minus a, x minus b, x minus c. So now what can we do? Well, we know this is equal to true because now we left the representation of polynomials. So this is a representation of polynomials that we already know exists. So now, if we know this is true, how do we find the value of this expression? We can just plug in negative 3 to our expression. Let's say this is p of x, right? P of x. Then that means we have p of negative 3. Then we have p of negative 3 will be equal to negative 3 minus a times negative 3 minus b times negative 3 minus c. Right? Because we know that p of x is this quantity. So we can just plug in x equals negative 3 to get p of negative 3 is going to be negative 3 minus a times negative 3 minus b times negative 3 minus c. And that is the expression that we have for t, negative t. So we know p of negative 3 is negative 3 minus a, negative 3 minus b, negative 3 minus c. And we know that p of negative 3, let me just move this down so I can get some more space on top. We also know that p of negative 3 will be equal to negative 3 minus a, negative 3 minus b, negative 3 minus c. So now what we can do is we can just say that, okay, if this is equal to negative t, we can just say that p of 3, negative 3 will also be equal to negative 3 cubed plus 3 times negative 3 squared plus 4 times negative 3 minus 11, which is equal to negative 27 plus 27 minus 12 minus 11, which is negative 23. So now we know that p of negative 3 is negative 23, and this is equal to negative 3. And this p of 3, negative 3 is just this, right? Remember, we see that these expressions are the same. So now we know that negative t is negative 23, t is 3. Okay, so now let's take a look at our next problem. So I'm going to look at some inequalities and optimization problems. Okay, so let me just re-explain this problem really quickly. Okay. So now we know that 1996 Amy, we have this expression here. So what can we do really? So what do we know, right? So we know that, well, we know that we have this quadratics. We can use Vieta to find the three expressions. So we have that a plus b is c, ab plus ac plus bc is 4, abc is 11. So then we have that a plus b is negative 3 minus 3, a plus c is negative 3 minus b, b plus c is negative 3 minus a. So we can substitute them back in to get that. We have in our expression negative 3 minus c, negative 3 minus b, negative 3 minus a. The product of those expressions will be p of negative 3. So p of negative 3 is equal to this expression, which is going to be equal to negative 23. And that expression is nothing but negative t, as we found by Vieta's formula, by making the substitution that a plus b is negative c. Yeah, t is 20. Oh, sorry. That was a. I miswrote. I meant that t is 23. Yeah. T is 23, yes. Sorry about that. So I was just saying that we can summarize. Basically, we find p of negative 3 in two ways, and then we equate them together to get the value of t based on our Vietas that we just did. Now let's take a look at some inequalities and optimizations problems. What is the least possible value of x plus 1 times x plus 2 times x plus 3 times x plus 4? So 2019, where x is a real number. So how can we find out this expression? Well, what we can do is we can say that, okay, this is really complicated. And how can we actually do this? So what we want to do is we want to see that, okay, what does this expression really mean? How can we find the minimum of this complicated, weird polynomial? The idea to find this complicated expression is to say that symmetry is this really great idea that simplifies a whole lot of things for us. So complicated things, if you use some symmetry logic, we can make those complicated things into something really nice and simple. No, we don't have to expand the product. There's a much easier way. So the idea here is, well, let's just see that what is the minimum of x plus 1, x plus 2. Okay, so basically the idea here is make a substitution. And I'll give you a minute to try this from here. $20 and 29 is not the correct answer, because the x does not necessarily have to be an integer. X does not necessarily have to be an integer, so this 2029 is actually not right, because x can be some other random number. Okay, so I'm going to give you a small hint here. So make a substitution, y equal to x plus 2.5. So make the substitution and see what you get. And the reason you make the substitution is because y equal to x plus 2.5 is like the middle. It's the average of all these terms. So it's like a middle, kind of a middle point. So you're trying to take advantage of symmetry. Because this whole expression is symmetric around y equals x plus 2.5. That's a hint. Okay, so this is a really clever problem. This is a really nice solution. So you make the substitution, as I already said. So you make the substitution, what do you get? Well, then you know that x plus 1 is just going to be equal to y minus 1.5. X plus 2 will just be equal to y minus 0.5. X plus 3 will just be equal to y plus 0.5. And x plus 4 will just be equal to y plus 1.5. Okay, so now these are expressions for x plus 1, x plus 2, x plus 3 till x plus 4. We substitute them in, we get y minus 1.5 times y minus 0.5 times y plus 0.5 times y plus 1.5. So then the idea here is you have these terms, y minus 1.5, y plus 1.5. Y minus 0.5, y plus 0.5. Yes, exactly, difference of squares, that is correct. We can use difference of squares to combine these terms. So we do y minus 1.5, y plus 1.5, combine them together using difference of squares to get y squared minus 1.5 squared to 2.25 times y minus 0.5 times y plus 0.5, or y squared minus 0.25. So now we have, again, another somewhat complicated expression. So a hint here is to continue, is to make another substitution, yet another substitution. So that here is, again, what is this middle, what do you think is the middle point in this expression? You can put in the chat, what is the middle point in this expression? What is this expression? I was not adding this plus 2019 here, but this plus 2019 is not really needed. We'll add that at the end. So I've kind of ignored this for now, but we can also add them at the end. So what do you think is the middle point in this expression? What is this expression symmetric around? So basically, this expression is symmetric around y squared minus 1.25. Right? Because you can think about y squared 1.25, it's the middle. It's the average of these two terms. Yeah, looks like that you were saying it. Y squared minus 1.25, this expression is symmetric around. So let's say that z, another substitution, is equal to y squared minus 1.25. Then we can say that, okay, this will be z minus 1. This will be z plus 1. And what is the value of this? Z squared minus 1. And then let's just put our 2019 that we didn't have the whole problem. Let's add that back here. So plus 2019, which is z squared plus 2018. And what is the minimum of this? The minimum of z squared is just 1, is 0. Because the minimum of any perfect square is 0. How do you find the middle value? Somebody's asking. The middle value is basically, you can just think of a symmetry. So you have this expression here. So the middle value is the average. You can think of it as the average of all four terms. So in this case, our middle value was x plus 2.5, because x plus 2.5, think about it. X plus 2.5. X plus 2 was 0.5 less than x plus 2.5. X plus 3 was 0.5 more than x plus 2.5. X plus 1 is 1.5 less than x plus 2.5. X plus 4 is 1.5 more than x plus 2.5. You can see these orange terms are symmetric, and these blue terms are also symmetric. So in this z squared, the minimum of z squared is 0. The minimum of any perfect square is always 0. That's a fact that it's always true. So the minimum of this overall expression is just going to be 2018, which is the answer. And this was like the motivated way of solving it, and there's a much shorter way of solving it, but that's like not sure how you decide to do that. This is like the kind of unmotivated way of doing it. Is just say that you do x plus 1 times x plus 4, x plus 2 times x plus 3. So let's use different colors just to make it clear. So you multiply the green terms, multiply the orange terms. The green terms have a product of x squared plus 5x plus 4. The orange terms have a product of x squared plus 5x plus 6 plus 2019. And then you can use difference of squares to get this is going to be x squared plus 5x plus 5 minus 1 times x squared plus 5x plus 5 plus 1. So x squared plus 5x plus 5 minus 1 times x squared plus 5x plus 5 plus 1. And then let's just move this down. Then we can just use difference of squares here to get it's going to be x squared plus 5x plus 5 squared minus 1 plus 2019, which is, and the minimum of this is again 0, and this is just going to be 2018. And this is the shortest way of solving it, but it's a bit unclear how did you just decide to multiply these green terms and orange terms. That's why I took the long route with assigning variables and using symmetry, because that gives a much nicer solution here, because that gives you that insight of how you actually think of it. In general, the key idea is symmetry. It's always going to be symmetric around some number. This number is symmetric in between. Okay, so I'll take a look at this problem from this last year's AMC 10. If you took it, you probably remember this problem. And basically the idea here is you're multiplying 100 terms, and you want p of n to be less than or equal to 0. So when will p of n be less than or equal to 0? Either we must have we want to have p of n be less than or equal to 0, we want to have 99 of the terms be negative and 1 be positive, or we want to have so the idea here is we want to have an odd number of terms be negative and the other terms be positive. So let's take a look at what's going to happen. We're multiplying these 100 terms, right? And it will be negative when an odd number of terms are negative and the other terms are positive. Because if we're doing -1, if we're multiplying an odd number of negative terms, then it's going to be negative. Because odd times odd, negative times negative is positive. So we want to have an odd number of negative terms in order for the overall product to be negative. Hopefully that makes sense. So for example, if we will do -3 times -2 times -4, this is going to be -24. Because we multiplied 3 negative terms, so an odd number of negative terms. But if we did just -2 times -4, for example, now it's going to be 8, a positive number, because we multiplied an even number of negative terms. Okay, so hopefully that made the problem statement clear. So now we can have either one term be negative. So the first case is we have 99 numbers be negative. Because with 99 numbers negative and 1 positive, then we have a negative number overall. So 99 terms positive, 99 terms negative. How can we have 99 terms negative? Well, the number x has to be between 1 squared and 2 squared. Because if x is between 1 squared and 2 squared, inclusive, it has to be inclusive, then it will be equal to, and remember here, it's p of n is less than or equal to 0. So that means p of n has to be less than or equal to 0, meaning that it's okay if it's equal to 0. So that means x can be either between 1 squared and 2 squared inclusive. So if it's 1 squared or 2 squared, any of them, then it's going to be 0, the expression. Similarly, we can also have x be between 3 squared and 4 squared. Okay, so if x is between 3 squared and 4 squared, then these first 3 terms will be positive or 0. And then the last terms will all be negative. or 0. Okay, 0, just make the whole expression 0 and then we're good. Inclusive, again. Similarly, x will be between 5 squared and 6 squared inclusive, all the way until between 99 squared and 100 squared. Okay, so how many numbers are between 1 squared and 2 squared inclusive? That's just going to be equal to 2 squared minus 1 squared plus 1, which is going to be equal to 4. So, yeah, 4. And if you remember from one of the counting classes, the number of terms between 1 squared and 2 squared inclusive, or I should actually explain why. So basically, we want to do 2 squared minus 1 squared plus 1. Because between two numbers inclusive, we do, if you remember from the AMC fundamentals class earlier, we do the first term minus the second term plus 1, because we're doing inclusive. And this will be that. And this will be 4 squared minus 3 squared plus 1. This will be 6 squared minus 5 squared plus 1. All the way till 100 squared minus 99 squared plus 1. So how can we find out the value of this? This is equal to 2 minus 1 times 2 plus 1. Difference of squares. Difference of squares is very useful, so definitely you should know that. Because 2 squared minus 1 squared is 2 minus 1 times 2 plus 1, and then we add 1. This will be 4 minus 3 times 4 plus 3 plus 1. Right? Because we're just doing difference of squares again. This will be equal to 1 times 3 plus 1 is 4. This will be equal to 1 times 7 plus 1 or 8. So on. You can continue using difference of squares. All the way to this one will be equal to 100 times 99 times 100 plus 99 plus 1. And that will just be equal to 199 times 4 plus 1, which will just be equal to 200. And now it's the sum of 4 plus 8 plus till 200. That's just an arithmetic sequence. And if you remember from the AMC math counts class, we covered how to sum arithmetic sequences. So we can do the sum of an arithmetic sequence is just going to be equal to the average of the first and the last terms. The average of the terms is 4 plus 200 divided by 2, which is 102. And the number of terms is just 50. So number of terms is 50. So the overall sum is equal to 102 times 50, which is equal to 5100, the answer. We did it. Okay, so overall the summary was, you look at different cases and you sum them all up, and it adds up pretty nicely. Okay, now let's look at the next problem from the 2017-12A. For certain real numbers a, b, and c, the polynomial g of x equal to x cubed plus ax squared plus x plus 10 has 3 distinct roots, and each root of g of x is also a root of f of x, which is this polynomial, this ginormous polynomial here, right? We want to find f of 1. Okay, so this seems quite complicated, so let's just write it out for x cubed equal to plus ax squared plus x plus 10. Is equal to 0. So let's say our roots of this are r, s, and t. So let's say roots are r, comma, s, comma, t. Then we have that r plus s plus t equal to negative a over 1 equal to negative a. And then we have rs plus rt plus st equal to 1 over 1. Positive of that. 1 over 1 is 1. And then we have our st. So again, negative, let's write it in big. Negative, positive, negative, just to make it clear. So negative for the first one, positive for the second one, negative for the third one. Negative 10 over 1 equal to negative 10. Now we've got our 3 equations that are handy. So now let's take a look at our second one. This is g of x. Let's just draw a line here. This is f of x, g of x, sorry. This is going to be f of x. So for f of x, we have that x to the 4 plus x cubed plus bx squared plus 100x plus c is 0. And I'm not going to write all the Vieta's equations out because that's unnecessary. But the idea is basically the idea here is that we just use Vieta's negative, positive, negative. And I'm only going to do this Vieta for this term. So this will, let's say that the roots are rs and t of this. And we're given that this has 3 distinct roots. And then each root of g of x is also a root of the polynomial f of x. So f of x has the same 3 roots of g of x and another root, so 0. So let's just say f of x has roots of r, s, t, and u. So r, s, t, and u. Okay, so if it has roots of r, s, t, and u, we have that r plus s plus t plus u equal to negative 1 over 1, or just negative 1. Then we have, I'm just going to write them out just to make it clear, hopefully, because I don't want to make this confusing. But it's not really needed to write them all out. I'm just writing them for the sake of making it clear. So I'm just going to write out the whole product expansion. This will be equal to, that's just going to be equal to negative, positive. So b over 1. So b. And then the next one, we have the product one. So rst plus rsu plus rtu plus stu equal to, that's going to be equal to negative, or I should have written that earlier, negative, positive, negative, positive. So it's 4 this time. Or that's not very clear, actually. So sorry about that. I'm just going to write it here. So negative, positive, negative, positive, negative, positive. So negative on the first one, positive on the second one, negative on the third one. So we do negative of 100 by 1, which is, oops, negative 100. Okay, so now we know that this is 100, and then we can also do the last one, RSTU equal to C over 1, which is just C, positive, remember, for this one? So now what can we do? Well, the only thing we need to know here is this blue one I made. The blue one is really the only thing we need to know. And so I'm just going to hide all the other ones for now. I'll just erase these ones because we're not going to use them. So I'm just going to erase them. We're not going to use them now. So now what can we do here is we can actually see that this expression is factorable. We know the value of RST, right? From our other polynomial, we know that RST is negative 10. So that's negative 10 plus we've got u constant in all these terms. So since we got u constant, we can just factor u times rs plus, let me just use a different pen here. U times rs plus rt plus st, right? I just factored it out. I factored out the u and I converted this to rs, rt, st. Which is negative 100, meaning that u times rs plus rt plus st is going to be equal to negative 100 minus, it's going to be negative 100 plus, so we add 10 to both sides to get negative 90. Okay, so now, does rs plus rt plus st seem familiar? This will be equal to 1. So u times 1 is negative 90, or u will be negative 90. Okay, so now we know that u, the fourth root, is negative 90. So if the fourth root is negative 90, we can just substitute that into our equation here. Negative 90 is negative 1. So we add 90 to both sides to get r plus s plus t equal to plus 90 to both sides, we get 89. So now we know that 89 r plus s plus t. Again, we're redirecting back to our Vieta's equations. This is equal to 89. meaning that a equal to negative 89. Okay, so now what? Now this is a tricky step of the problem. The idea here is now to say that, okay, we want to find f of 1, right? So we use the same factorization of polynomials. So we know that x cubed plus ax squared plus x plus 10 is equal to 1 times x minus a times x minus b times x minus c, right? This is the factorization of polynomials that we have. The next thing is that we have our next polynomial, x to the 4th plus x cubed plus bx squared plus 100x plus c will be equal to 1 times x minus a, or why am I writing a, b, and c? That's very, I should have been written s, r, s, and t. That was an accident to write s and t, sorry about that. Not a, r, s, and t. r, x minus s, x minus t, and x minus u, but u is negative 90, so x plus 90. Okay, so now what? Well, now what we can do is we can see that we really just want to find, this is just going to be this first part is just f of x. So you know that f of x, right? This is f of x is equal to this large polynomial. F of x is equal to, well, this part is common. It's just going to be x minus r times x minus s times x minus t, which is g of x times x plus 90. And g of x times x plus 90. So now we know that f of 1 will be equal to g of 1 times 1 plus 90, or 91. So now we really just need to find g of 1 in order to find f of 1. Now we can very easily find g of 1 by just plugging it into our polynomial. So again, we know that a is negative 89. So g of x is negative 89. So we can, let me just erase these part. Let me just erase these. So we can make a into negative 89. So we know a is negative 89. And now we can just plug in, this is g of x. G of x is equal to this. So now to find g of 1, we can just do g of 1 equal to 1 cubed minus 89 plus 1 plus 10, which will be negative 78. So now we just plug it into our final expression. So as you can see here, g of x is equal to the sum here, which is going to be x cubed, which is 1, plus negative 89, plus 1, plus 10. Okay, so now what can we do? Well, we see that this is just going to be equal to 1 cubed minus 89. So 88 plus 1, which is 89, plus 10 is 79. Negative 77, sorry, I made a computation error there. So now we just do negative 77 times 91, which is negative 7,007, the answer. I know this was a tricky problem. This is a tricky problem, a very tricky problem. So to summarize the key ideas is we find f of x in terms of the roots, which was r s plus c, r s, rt, st, r st. And then we also use this other polynomial when we write our Vieta's equations. Okay, so this is a hard problem. I definitely agree. This is actually an AMC 12, number 23. So the idea here is we see that g of x is x cubed minus 89x squared plus x plus 10, 0. We use Vieta's to get our equations here. So r plus s plus c is negative a, 1, and negative 10. We write our equations like standard. We write our negative, positive signs there. We write the equations out, but we don't need all of them. We only need these two equations. We really only need these two equations, and the second one here. And then what we do from here is we factor this expression. We know the value of r is t, so we factor out the u to get this term here. And then we summarize from there. So overall, we just do u times this quantity, and we see that u will be negative 90. So overall, we get that expression. So f of 1 will be 7,000, negative 7,007. Okay, so that's it for today. This is the last problem for today. Thank you all for coming. Next class, raffle winners will be announced, and we'll have more raffles in future classes too. So we'll have raffles in all our classes. So please make sure to come to the classes because we'll be covering many more important concepts that come on the AMC 10. You can check out the website for more information about the schedule. And that's it for today's class. There's no homework, but there'll be a review problem next class to test out the skills that we learned in this class. So you can check out the resource page for more information on how to prepare for AMC 10 and 12.